Hello everyone, my name is Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem that is form a palindrome. First of all, let us start by understanding the question. What does question say? Given a string, find the minimum number of characters to be inserted to convert it into a palindrome. So what are the minimum characters which we can insert in the string so that it gets converted into a palindrome? What is a palindrome? It is a string which reads the same from start to end and from end to start. Now here it is not mentioned that which position to enter characters and what characters to insert. Means we can insert any character at any position as we wish. Okay. For example, if your string is A, B, you can add a at the end or B in the starting to form a palindrome. So you get BAB or ABA, and so the required answer is 1. If the string is AA, it is already a palindrome. You do not need to add anything. If the string is ABCD, you need to add 3 characters at least to make it a palindrome. Okay, this is an example. You don't need to read input or print anything. Your task is to complete the function countMin, which takes the string str as inputs and returns the answer. The expected time complexity is n square, where n is the length of the string, and expected auxiliary space is also n square, and the constraints are given here. So now if we think about solving this problem, then basically see what we have to do is we are basically given a string and we need to tell what are the minimum number of characters to be inserted in this string. So any character can be inserted at any position as per our wish, so that this string becomes a palindrome. Okay, now you understand one thing. What I can basically do is I want to find the minimum number of characters to be inserted such that the complete string becomes a palindrome. So what I can do is, now if you look at the palindrome carefully, it is the string which reads the same from starting to end and from end to start. So if you draw a line in between of the string, then then there are pairs forming at equal distance from the center. For example, if I have a string A, B, C, D, E, D, C, B, A. So the center character is this. So A and A are matching, B and B are matching, C and C are matching, D and D are matching. Are you getting my point? If you have A, B, 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 A. So this is the center line. A and A are matching, B and B are matching, B and B are matching. Are you getting my point? So what I know is, if I draw a line at the center, every character has a pair with it, associated with it. Okay. So what I can do is, if I find the longest palindromic subsequence from my given string, then for the remaining characters, I will insert one character so that they also form a pair and form a palindrome. Please hear it again. For I want to insert the minimum number of characters. So what I will do is I will find the longest palindromic subsequence. So the already longest palindromic subsequence which is present means there are characters which are already forming pairs. The maximum number of characters, I will take that and remove them. Then the remaining characters which do not have a pair associated with it, for them I will add a new character. And since I removed the longest palindromic subsequence, so the remaining characters would be as minimum as possible. And for those characters, I will add one new character each so that the complete string becomes a palindrome. For example, let's say my string is A, B, and C. Okay, here we have P, here we have Q, here we have Z, and here we have Y. So what is the longest palindromic subsequence here? It is A, B, P, B, A, or A, B, C, B, A, or A, B, Q, B, A. Any of this. Let me take A, B, P, B, A. Okay. So this is the longest palindromic subsequence. So what are the remaining characters? C, Q, Z, Y. The total length is what? 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 is the length of the longest palindromic subsequence. Since this is the longest, the remaining characters will be minimum. Now I need to add a character for each of these characters so that the complete becomes a palindrome. Because this A has a pair with this A, this B has a pair with this B, and this P is alone in between. If I add a pair for C, if I add a pair for Q, if I add a pair for Z, and if I add a pair for Y, the complete string will become palindrome. So my original string is A, B, P, C, Q, B, Z, Y, A. Okay, this, and this are already a part of palindrome. Now I want to add a pair for C. So you look here, what is the center point that we are looking at? We are looking at the center point as P. Are you getting my point? So this is my center point. So where is C? C is between P and B. Q we have not taken yet. So C is between P and B. So between P and B, if I add a C, so the pair for this is formed. Now where is Q? It is between C and B. So between C and B, I'll add a Q here. Okay, so basically between B and C, I will add a Q. So it will become ABQ. Okay, now so this is done, this is done. Now Z is between B and Y, basically between B and A. Okay, so what I will do is I will add a Z between A and B, and Y is between Z and A. So I will add a Y between Z and A. Now you look at from this point, A has a pair with A, Y has a pair with Y, Z has a pair with Z, B has a pair with B, Q has a pair with Q, and C has a pair with C. So this is a palindrome. Are you getting my point? So since we want to find the minimum number of characters to be inserted, we find the longest palindromic subsequence length, and for the remaining characters I need to insert one character each. So if the longest palindromic subsequence if the length of the longest palindromic subsequence is m and the length of the string is n, then for the remaining characters, that is n minus m, I need to insert one character each so that it becomes a palindrome. So my answer will become n minus m, where n is the length of the original string, m is the length of the longest palindromic subsequence. Now let's see how can we find the length of the longest palindromic subsequence in an efficient way. Okay, so we want to find the length of the longest palindromic subsequence. Okay, now you understand one thing. What is a palindromic subsequence, or what is palindrome? It is the string which reads the same from start to end and from end to start. So if I reverse the original string completely, then also my longest palindromic subsequence will be present in it, because palindrome reads the same from start to end and from end to start. So if I reverse the complete string, then also my longest palindromic substring will be present, subsequence, sorry. So let's say my string is this one only. Okay, let me take this example only. So I'll copy it and let me paste it. Okay, so this is my string. Now you see here the longest palindromic subsequence is A, B, P, B, A, right? So if I reverse the complete string, that is A, Y, Z, B, Q, C, P, B, A, then also I will get A, B, P, B, A in this order, because this is a palindrome. It will read the same from start to end and from end to start. So it is also present in this string. So what I can do is, let's say if this is my original string S and this is my reverse string R, then the length of the longest palindromic subsequence in the original string S will be same as the longest common subsequence between S and R. Are you getting my point? So now my question boils down to finding the longest common subsequence between S and R. The longest common subsequence between S and R is this only, A, B, P, B, A. So now how can we find longest common subsequence? We can recursively call. So what I will do is, see, both the string has length n. So I can call a function n comma n, which will return me the length of the longest common subsequence considering the first n characters of the first string and considering the n characters of the second string, where second string is the reverse of first string in this case. So if the last character of both this string matches, let's say it does not match, so the longest common subsequence considering n characters of first string and considering n characters of second string will be longest common subsequence considering n minus 1 characters of first string and n characters of second string, or considering the n characters of first string and n minus 1 characters of next string. Because if the last two characters are not same, then we need to drop at least one of the characters from the string and then keep on matching further. So my equation becomes this. But let's say there is a match, means the n minus 1th character of first string and nth character of second string are same. So we take them into the longest common subsequence. So the longest common subsequence considering the first n minus 1 characters of the first string and n characters of the second string is 1 plus the longest common subsequence considering the first n minus 2 characters of first string and n minus 1 characters of the second string whenever we get a match. Okay, so whenever we get a match, we subtract 1 from both of them, because we consider the last character from both the strings into the longest common subsequence, and we add 1 because of that only. And whenever there is a mismatch, we remove one character from this first string and one character from other string and take two choices. Okay, so now this is the thing. Then again I can go here, I can say here it will be, let's say there is no match, so this will become n minus 1 n minus 1, or it will become f of n comma n minus 2. Okay, again let's say there is no match, so this will become f of n minus 2 comma n minus 1, and this will become f of n minus 1 comma n minus 2. Are you getting my point? This is minus. Okay, so it will go on like this. And what will be the base case? Whenever one of the strings is 0, so we will return 0, because if one string is 0, it cannot have a common subsequence with other string, because there are no characters. So whenever this or this becomes 0, we will return 0, and this will be our recursion tree. Now since this is the recursive way, the time complexity of this will go in exponential. So we need to think of something more efficient. Okay, so how can we solve this efficiently? See, whenever there is recursion, one of the efficient ways could be dynamic programming. Now for dynamic programming, we need overlapping sub problems. Can we see overlapping sub problems here? What are overlapping sub problems? These are the problems which are called again and again in the recursion. Yes, we can obviously see here also f of n minus 2 n minus 1 is called, and here also f of n minus 2 n minus 1 is called. If I draw the complete tree, I will get many more. So there are overlapping subproblems, so that I can convert this problem into a dynamic programming problem. So I will solve this problem using the tabulation method. Okay, now what will be my dp state table? Since here I have two parameters, my dp table will also have two parameters. Okay, so this will be my 2D array of dp, where dp of ij will denote the length of the longest common subsequence between first string and second string, considering the first I characters of the first string and first j characters of the second string. So now I want to fill this table. So, and finally what I will get in dp of n comma n, I would get the length of the longest common subsequence considering first n characters of first string and n characters of second string, means basically complete strings. Okay, so now I need to fill this table. So first of all I will fill the base cases. So base cases for I equals to 0 to n minus 1, dp of I0 equals to dp of 0i is equals to 0. If one of the strings is 0, irrespective of the length of the other string, the answer is 0. Because if one string is 0, then the length of the longest common subsequence is 0 only, right? Now for the remaining cases, what I can do is, for I equals to 1 to n, and for j equals to, let me write it a better way. Okay, for I equals to 1 to n, and for j equals to 1 to n. Now I want to calculate dp of ij. So if there are two things, if the ith character and jth character of both the strings are same, or they are not same, so whenever they are same, we will call this, we will use this condition. Okay, now the ith character of the first string and the jth character of second string will be present at I minus 1 index and j minus 1 index respectively. So if s of I minus 1 is equals to r of j minus 1, then I can say dp of ij is equals to 1 plus dp of I minus 1 and j minus 1, like how we used here. Else if they are not same, then dp of ij is equals to max of dp of I minus 1j comma dp of ij minus 1, right? Like how I called here, it will be max of this or this. Okay, it will be a max call, it will be a max call, it will be a max call. Okay, so it will pass, and the whole table will be filled of n cross n size, and finally I will get dp of nn, which is the length of the longest common subsequence. And what will be my answer? This is the length of the longest common subsequence in S and R, where R is the reverse of S. So it is also the length of the longest palindromic subsequence in string S. So for the remaining characters, I need to insert one character each, and that would be minimum number of characters. So my answer would be n minus dp of nn. Okay. and I will return this. What would be the time complexity? It would be big of n square because we are using two for loops here. And what would be auxiliary space? It will also be big of n square because we are using this DP table of size n square. Now let's look at its actual implementation and submit this code. So if you look at the actual implementation, so I have taken n as the length of the string and I have taken this DP table. In R I have taken string and then reversed it. So R contains the reverse of the string. Then I have filled the base cases and then I have traversed and fulfilled the whole table. And finally returned DP of n minus finally I have written n minus DP of n. Now let's submit this code. Okay, so let's submit it. Okay, so we have solved this question successfully. I hope you have understood the solution completely. Thank you.